Welcome back. Welcome back to MPB Learning with me, Ms. Killen. We are in Unit 2, Equations. We are going to be looking at equations or no equations. I can evaluate the value of a variable and then calculate if that variable will help create an equation. We are also looking at A-REI.1. So let's go ahead and dive on in to our lesson. It says correct grammar. Now you're sitting there going, wait a minute. This is our math. Yes, it is. But we still have grammar and grammatically correct sentences in math. So let's look at these. So correct grammar in ELA, I can eat dinner, then I can go to the movies. This is a grammatically correct sentence. It has nouns, verbs, adverbs, and prepositions that make the above a complete true sentence. So then we also in biology look at all living organisms are made of cells. This is a true biological statement. The reason is a foundational concept of the cell theory in biology. So then we're looking at things that are grammatically correct. We're making sure that our sentences are true. So let's look in mathematics. It says in math practices and concepts, we also have true grammatically correct sentences. We use numbers, variables, and symbols to make grammatically correct sentences. So if we're using numbers, we have 3 plus 7 equals 10. Using variables, A equals 12a plus 6. And then we have a combination, which is 3x plus 7y equals 21. So these are grammatically correct. We have our numbers, we have our variables, we have some type of equation sign or maybe an inequality symbol. And then we have our answer or product or whatever type of operation we're doing. So let's look at this. 6 plus 4 equals 2 plus 8. This is a grammatically correct sentence. This is true because 6 plus 4 equals 10 and 8 plus 2 equals 10. So we can say this is grammatically correct and it's a true sentence. I can say I am 6 feet 12 inches. Okay, I'm not. I'm only 5'4". So that's a sentence, yes, it's grammatically correct, but it's not a true sentence. This is a true mathematical sentence. We have seen examples of number sentences. Number sentences is a statement of equality between two numerical expressions. So these are two very important vocabulary that we're wanting to put on those pages that we're using for our new vocabulary or our vocabulary sheet. We're wanting to make sure that we're getting these new vocabulary because we're going to see them throughout mathematics and we're going to see them through this Algebra 1 course. The number sentences are true if both numerical expressions equal. They're false if they don't. So let's look at this. Let's kind of dive and see what we have here. So this expression equals 10 and this expression equals 10. Therefore, I can say that whole equation equals and it's true. So that's what this is saying of it's true if both expressions equal, and they do equal. All right? Depending on true or false, we'll show the truth value. Now you're sitting there going, truth value, I've not really heard about that. Well, let's look. It says in algebra and more in logic, we use truth values to check if equations or inequalities are correct. These are correct. Solve problems by seeing what values make the sentences true or the statements true. When we start using more of our variables, then we'll really start to see, can I use this number to make it true, or I can't use this number to make it true. So we're really looking at to see what values would make the sentence true or the statement true. And understanding how combining true-false statements work in more complex math later on. Now, this is just Algebra 1, but you're going to get into higher maths. And depending on what concepts you're working on, depends on about these true and false statements, how you're going to work them. All right, so let's do some practice. Read the sentences, tell if they are true or false, use your technology tools to help. Now you're probably sitting there going, Ms. Killen, what do you mean, technology tools? We have our Desmos calculator, and we also have our TI-84 calculators. So I want to show you how you can take these just like they are and use Desmos. So let's go ahead. Now, we have these written down or we have them on our notes page. So let's go to Desmos and plug them in just the way they are. So here we go. All right, so I'm going to plug the first one in just the way it appeared on my screen. So I have 14 plus 3, and that tells me it equals 17. So I'm going to put the next expression in, 9 plus 12. Now, Ms. Killen, I have one part of it that's 17 and one part of it that's 21. So what could I say about that number sentence? You're right. I would say this one is false. And if my questions ask me to justify my answers, I would say this equals 17 and this one equaled 21. All right, let's put number 2 in Desmos and see what that looks like. Okay, so here we go. I am putting parentheses 80 times 501, close parentheses, times 32. Whew, 1,282,560. That's a big number. So let's see the second part of that sentence. So for my second part, I'm going to go to my next entry, and I'm going to put 80 times, open parentheses, 501 times 32, close parentheses. I have the same exact thing. So it shows me here, this one equals the same as this one. So when I go back, I would say that this is a true mathematical sentence. All right, let's look at number 3. All right, Ms. Killen, we've got some fractions, so let's look. So I'm going to put a fraction in. Well, Ms. Killen, how do you put a fraction in? Well, first, I'm going to put 1 divided by 3, and Desmos is so smart, it knows, hey, that's a fraction. So I have 1/3. I'm going to arrow over plus. Then I'm going to do another fraction by putting in 2 divided by 5. There's my fraction. Now, Ms. Killen, that is a decimal. It doesn't see what that decimal is. It just gives me that 0.73 repeating. So I'm going to put the second part of my sentence in. I'm going to put 11 divided by 15. What do you know? It's the same exact thing. So even though it's not showing me in decimal form, it's not showing me in fraction form. I can put the fraction that I know, and it will tell me what that decimal equals. So I can go back to my problem and say, this is true. All right, Ms. Killen, number 4 looks a little wonky. All right, so let's put that in and see what we've got. So I'm going to put the first part, which is a parentheses, and I have 4 plus 9. And I'm going to put that to the second power, and it gives me 169. So then I'm going to put the second part in there. 4 squared plus 9 squared. Whoa, that's a little bit different. So if it was money, that would be a lot of money. That's a difference. So what could I say about this problem? Exactly right. It's false because those do not equal each other. So we've seen how we have to look at one part of the equation to equal the other part of the equation. We've seen how we can put these in our technology tool, Desmos, exactly like they are, and it'll tell us what it equals. So at this point, we've got the tools to answer these type of problems, even our Desmos or calculator, or we just do the math. All right, so let's look at the next one we got. Algebra equations. So when I'm looking at algebra equations, what does that mean? What does that look like? Well, I know an equation's got to have specifics. So let's see what it says. Algebra equations are also number sentences. They're a statement of equality between two expressions, can be just a number sentence with numbers, but many times and more often contains variables that are unknown. Now, we've seen that 3 plus 4 equals 5, and we've seen different things. So when I'm looking at an algebra equation, more specifically an equation, It's got to have that little sign. So let's look over here, our for instance. So when I see this, it says, are these two expressions equal? Why or why not? So let's see. I've got 5 being multiplied to that whole parentheses. So I could say I could multiply everything in the parentheses by 5 and see what I've got. So I've got 5 times y would be 5y. 5 times a positive 3 would be 15. Well, I just rewrote what was on the right side of my equation. So are these two expressions equal? Yes, they are. Why? Well, I just proved them. Okay, do we know what the value of y is? No, at this point, we don't know what the value of y is. So we're just going to leave that there at the moment. They're equal. 5y plus 15 does equal 5y plus 15. Let's go and see what we got. The difference between the expressions we have seen and used plus or and the equation is just one symbol. And here's the symbol that we've used. This one symbol speaks huge volumes. So when I look at the word equation, it literally looks almost like the word equal. I'm just missing one letter. So I can say when I see the word equation, I'm thinking it's got an equal sign, it's got an equal sign, it's got an equal sign. That's going to make a difference between understanding what I'm doing with an expression or how I'm working an equation. That one word, that one symbol speaks volumes. All right, so let's look at our next slide. It says try this. What can we put in for T to make this a true number sentence? So I'm going to give you a minute and let you work it while I work it. Then we're going to come back and talk. All right, so Ms. Killen, what did you do? I wanted to know what I could put in for T to make this number sentence true. So what I did was get the T by itself. So I moved everything over to the other side, and I got that 15 minus 3 equals 12. So what can I put in for T? I can put in 15 for T to make that sentence true. Is there any more that can make this true? Is there any more answers, or is there just one answer? There's just one answer, because there is 15 minus 12 equals 2. There's nothing else that I can say this minus 3 is going to equal 12. So I'm going to put 15 as what I'm plugging in. Is there more than one answer? Nope, there's just one. All right, go ahead and try this one by yourself. I'm going to let you work it, I'm going to work it, and then we're going to come back and see what we got. All right, have you ever had $0 but also had $6? No, you're either broke or you got money. So can 0 equal 6? Absolutely not. So is there anything that we can substitute in to make this true? No. So is there more than one answer? No. I cannot put anything in there that would make that sentence true. It's grammatically correct. Yes, it is. But it's not a true statement. All right, let's go. All right, time for you to master. Now, we're determining with the following which equations are true, correct sentences. Now, here's the thing. I want us to do the first one together, then we're going to let you work independently. I want to show you with this first problem, 3x plus 4 equals 61, where x equals 19. My calculator will plug this in just like it is if I tell the calculator exactly what to do. So go ahead and pull your calculator up. And so what I'm going to do, first of all, I've got to tell my calculator we're using a variable and what the variable equals. So I'm going to tell my calculator that everywhere in my next problem that I put in this calculator that x is going to be 19. To do that, I'm going to plug in 19. I'm going to hit the store button. The store button is when I say this is what this is. The store button is right above my on. So I'm going to hit 19 store for x, and my x is right beside my green alpha button. And I'm going to press enter. So now anytime that I put x in my calculator, it's going to be 19. So let's go back and put that expression in. 3x plus 4 equals 61. So that's exactly what I have on my paper. My calculator has confirmed it without me having to go in and substitute or anything like that. So when I go back to my problem, can determine if it's a true sentence, this is exactly a true sentence. So what I want you to do now is pause the video. You and your partner work. Use the technology that we've got. Use this new feature on our calculator. Use that store button. You put the number, store, and then the variable. And then you just plug in the expression to see if it equals. Okay, so go ahead and pause the video, and then we'll see what we got when we come back. Okay, so now that y'all have dived deep into these problems, now that you've used the technology, I'm going to go ahead and work with the technology to see if I can come up with the same answers that you got. So the first one down here says 4 plus y plus 7 minus y equals 20, where y equals 3. So I'm going to go ahead and pull up my technology, and I'm going to plug that in. First, I'm going to tell my calculator that every time I see oh, Miss Killen, I don't see a y. You don't. But does it matter if we put the y or the x? No, it doesn't. So I'm still going to use the variable x. So I'm going to put 3 store for x, enter. Then I'm going to put my expression, 4 plus my variable plus 7 minus my variable equals 11. Well, that's not what my paper says. My paper says 20. So then, since I went ahead and stored my number and it gave me 11 as my answer, I can go back and I can say this is a false statement. All right, so let's look at the next one. 9 equals 3x minus 2, where x equals 2. So I'm going to pull up that calculator. I'm going to tell my calculator everywhere I see my variable is going to equal 2. So 2 store x, enter. You have to press enter to say I'm finished telling you what to do. So always make sure once you put your number, the store, the variable, make sure you press enter to say I am finished with the command. So let's go ahead and put this in. So my equation was 9 equals 3x minus 2. So I'm going to put in 3x minus 2 equals, and I have a 4. Well, on my paper, it says it's 9. So what can I say about this? This statement is false. All right, let's go to the next one. I'm going to put that everywhere I see my variable is 7, so 7 store x, enter. Then I'm going to put 2x minus 8 is 6. On my paper, it also tells me that it is 6, so I am going to put true. Let's do our next one. So I'm going to tell my calculator that my variable is going to be 27. Press enter. So now I've got to put 1/3 variable plus 5. Remember, to put a fraction in our calculator, we do what? Alpha y equals. So let's go ahead and do that. Alpha y equals numerator over denominator. So I'm going to put 1/3. I'm going to arrow to the right to get out of that fraction my variable plus 5, and I get 14. That's exactly what's on my paper. So I'm going to go back and put that this is a true statement. So now I'm going to do the last one. 3 plus y divided by 5 equals 4, where y equals 3. So I'm going to go back to my calculator. I'm going to tell my calculator everywhere I see my variable, it is a 3. Press enter. So now I'm going to put that fraction back in. Alpha y equals, I'm going to get that number 1. I'm going to put 3 plus my variable, scroll down to get to the denominator and put a 5. Scroll to the right to get out of the fraction, and I'm going to press enter. It gives me 6 over 5. Well, I know 6 over 5 is nowhere near what I have on my paper. So I can go back and say that this statement is false. So I've learned a new tool with my technology. So now I can store variable amounts when I'm wanting to use them. So that's a good tool to have with that calculator. Something I don't want us to forget, what grammatically correct mathematical sentences are. Remember, they don't necessarily have to be true. They just have to have your numbers, your variables, your operation symbols, and if it is an equation, it has to have that equal sign. Statements can be grammatically correct, but sometimes they're not true, but they're still a mathematical statement. What are numerical expressions? Remember, an expression does not have an equal sign. It is just 2x plus 3, or it's just x plus 1. It is just the expression itself. There's no equal sign. Then it says our true values. Our true values are helping us determine if these expressions or if these equations are true or are they false. And then our algebraic expression, which we've already talked about, having an equation. It has numbers, it has variables, it has sentences that are correct. We need to make sure that all of these are understood, because the more we get into these equations, the more we're going to use these different points. I am so glad that you came here to learn with me today at MPB. I am Miss Killen. I want you to have a great day.